Next, example 4.10. The force F at the end of the angle bracket, we need to determine moment of the force about point O. So, we're going to do for the first method, we resolve our F into X and Y direction. So for the tips, always remember this. When we have F at the angle of theta, when we convert into this axis, we're going to have F cos theta. And we convert to this axis, we will have F sin theta. Refer back to our question. If we're going to use this, we have to rotate that. So that means on the y-axis is F cos theta, while on x-axis is F sin theta. So we resolve that. So this one is F cos theta or F cos 30. This one is F sin 30 degree. Then we take positive is clockwise for moment at O. For F sin 30, to get to point O, it will be anti-clockwise. Therefore, it is negative because our initial assumption is positive is clockwise. And the perpendicular distance for that one is 0.2 meter. Then for F cos 30, to get to point O, the perpendicular distance is 0.4 and it is clockwise, therefore it's positive. Then solve that, we will have our M about O, 98.6 Newton meter. When we're going to write that in Cartesian, we're going to transform our answer in anti-clockwise. Therefore, it will be negative 98.6. So we get our MO in Cartesian vector. It is because our force in X and Y and it's resulted in K. That's why our answer is negative 98.6 K Newton meter. For the second method, we're going to use position vector of R and force in Cartesian. So we resolve our F into X and Y direction. Also, we have a distance here given 0.4 and 0.2. Then we can get our position vector is 0.4 I, then 0.2 J for our position vector, while for our F is F sin 30 or 400 sin 30 on I, then minus F cos 30 because that is on negative y-axis. That's why it's negative. So calculate that. We will have our F is 200I minus 346.4J for our F. Then we know for moment about O is R times F. So we assemble our Cartesian vector we calculated in vector form I, J and K for our R and our F. Simply we can calculate. As you can see here, when we expand our matrix, for I, J will be cancelled out because it's times by 0. Therefore, just left for us is K. So expand this, we will have 0.4 times negative 346 minus by negative 0.2 times 200. So we will get our MO is negative 98.6 K Newton meter. So that for the second method.